Hello my 8th grade students at ECOT, this is Mr. Duncan. I'm going to try to give you a hands-on way to try to understand how to work with combining like terms. I know I've had some students say that we haven't had many hands-on activities. So we're going to try one today to where you'll need a piece of paper, or somehow you need to be able to make sure you have x's and x squared. And I have this paper that I can send you so you can cut these out with some scissors. And you'll also need some areas of blank squares. This is going to help understanding like terms. So what I have already is I have some that are created. I have my examples on some note cards or cutout cards, x squared. And then I also have what we call constants. It's basically any number. I just use the number 1 consistently. If you want to, you don't have to write anything. You can just use blank. As long as you have some that you can manipulate and you can count and move around. So for this example, I'm going to have these represent just the number 1. And so you'll see as we go through this example how to understand combining like terms. And this is only going to be a good example of positive amounts. But just be aware that you can change. The variables can change. They don't always have to be x. They can be other letters as well. But the idea is that combining like terms, we're going to be combining and counting up all the x squareds. And so in this, we're going to assume that the constant, or not assume, but the constant is 1. Because I have one of these in my hand. We don't always have to write a number 1 in front of it. So with this, you'll know that anytime you have one of these, it represents 1. So if I have a stack of 2 of these, technically in our equation as we'll model it, would be 2x squared. So hopefully you can follow along, do this yourself as well, and we'll work through some examples of how to combine like terms. Alright, at this point I have all of the cards that I'm going to use laid out. So these are the piles that are just going to be the numbers, so I can arrange how many I put in a pile. These are the x's, so these are all like terms, all the x's are together. Don't focus on the color, but just worry about the type of term that you're seeing. And then we also have our pile of x squareds. So we're going to start with this example by setting these up to help resemble an equation, and then from there we will combine the like terms. Alright, so we're going to start off and I'm going to show you we have x squared here. I'm going to take 2 of them and create one stack. So right now we have 2x squared. I'm going to move over to what would be our constants. I'm going to grab 3 of these. So again, you can use it to where you have the number 1 on it, or you can just flip it over so you see nothing. So we have a pile of 3. I'm going to go back to x squared, and I'm going to create a pile of 2. I'm going to go to x, have just a single one by itself. Then I'm going to use a pile of 3. And I can put these in any order that I want. If you've ever seen a trick where you, I think it's in New York City, they move around the cups and you have to find what's underneath. If you want to, you can play around with moving these and rearranging the order. It's not going to change how much is in each pile. So remember, I still have 2x here. I can put it in the back. It doesn't matter which way I have these organized. So we're going to take a look at this example written down in its equation form. Alright, so look at your piles. I have 5 different piles. So you'll see this as I write it out, what this equation will look like. So I'm using addition because I'm using the total amount. I'm not using any negatives in this example. This is just to show positives. So if we go back to our piles, we can then see how we could combine the terms. But at this point, you might be able to see how which terms are similar and which ones you could probably add up now. So think of which stacks you're going to bring together as you total it up. Was to look at the terms. The x squared helps you know that this is a different term. The x lets you know this is a separate, and then having no variable or no letter next to it lets you know this is a third term by itself. So as you can see here in our equation that we have with the pieces, this first pile represents the 2x that we have in our equation above. This pile represents the 3 x's that we had stacked up within right here. The next pile we just had a stack of 3 individual. Again, you don't need to have the 1 on there, or you could simply just write the number 3. But this is a way to help you manipulate and move pieces around. Then we also had the individual x, nothing else was there. You assume that there's at least a 1 in front of it because there's just one x. And so right there in our equation we represent the x. Last we have plus 2x squared. So we have 2 of these x squareds. So now how we would go about this, you could go through and you just want to combine the pieces that are alike. So back here we have this piece here. We can bring it over here and just stack these up. So that was 2x squared plus 2x squared. So in this we should have in this pile we should have 4. 1, 2, 3, 4. So we had 4x squared. Next up, we'll notice we have these x's. this was a pile of 3. Bring this and combine these together because they're the same terms. And we have a pile of 1, 2, 3, and 4. In our equation, you can see that we are combining the 3x and the x. Since there is a term here, you're going to assume that's at least a 1 and only 1, unless they give you any other number in front. Remember, the number in front is going to be called the coefficient. So it's going to work with the variable. So in this one, we don't have a number, but if you don't see the number, you're going to assume that it's the number 1. So we can combine 3x and x and have 4x. And then last, we have this last pile of the individual ones. So we have a stack of 3. So it would be plus 3. So I'll show you this one last time in written form what it would look like. I'm going to show you the equation that we created in written form after we combine the numbers. So I've got my stacks of cards. So this is our equation that we have now. After we had it set up, we should now have 4x squared plus 4x plus 3. And the piles that I have, the plus 3 at the end, I had the 3 cards stacked up, which you should as well. For x squared, I had 4 total, which I still do, stacked in my pile, which represents the 4x squared from up here. And then, last but not least, the individual x's by themselves. These are all like terms because they're all the exact same kind. And so now you're just counting up and totaling or tallying how many you have total. So this original equation that we started with, 2x squared plus 3x plus 3 plus x plus 2x squared. Sounds like math gibberish, but your goal is to combine the terms that are the same. So you look at the variable, if they have a variable, this is x squared, over here is x squared. So you will count those and add those together. So the 2 and the 2, you would add those up, and you're given 4x squared. Next up, we have the 3x's and the x. You'll want to add those up together, so 3 plus the 1 that you have to assume that 1 is there gives you 4x. And last but not least, we're going to add that 3, which is all by itself. That is called a constant because it's not going to change. There's no variable there. Constant means it's going to be the same. So the number 3 is always going to be the number 3.